This video will show you how to create a simple structural steel model, including the components. In this view, I'm going to start to create the model. Let's say I'm going to create a structural steel column. So select this properties, steel column, and then you can specify the size of the profile. So let's say the profile is HA 400. So by clicking this profile, you can see the database of the profile, whether it is a European standard or American standard or even a British standard. So this one, at this point of time, I'm going to use the HA 400, apply, and then I can specify the top of the column, the bottom is 0. So this top and bottom is according to the global coordinates. Okay, so all I have to do is to pick this point, 1, and then 2, and then I can choose a different size. Let's say here I have the same attributes, column 2, HA 300 with the 3000 height. Pick that one, and then you have now these 3 columns. So in this column, you will notice that this one is on the middle position. So if you want to rotate this column, you can use this position here, either middle, down, or up. Down, and then modify, or up. Or just simply put a middle, or you can add the value here, let's say 100 from the middle. Okay, so you can play with this position, or you can again select the column and then look for this contextual toolbar. So this contextual toolbar, you will notice that there is a position here, then there is a ring. So this green button or green circular button here is something like a dial where you can rotate, so that you can see the rotation of the steel part. Alright, or you can just simply add the value here, let's say 180. Alright, again select this position. So here I can say 180 and then enter, or again go back to 90. Alright, so now we have this column. So the next thing is I'm going to add a rafter. So by simply picking again, select the shift key and then click the beam, and then you can see I have this default rafter here. The profile here is HA 200. Okay, again you can select the profile in the database, HA 200, apply, and then from here just simply click this center of the column at the top, and then from this grid line, okay, I can press the control key and then click. So that control key and click, it means I have a dummy position of my beam there, but that one is something like a dummy. So it means I can just simply specify the height of my beam here, or the apex. Okay, so let's say I'm going to select in 6500, click. So I have now this HA 200. Okay, or maybe I'll just change this one to a bigger one, HA 300. Okay, and then select again the beam, and then pick again the center of the column, the top, and then pick the handle of the other rafter. Now you have this rafter. Now, if you want to work on the 2D view, all you have to do is to go to this view or Control B. Okay. So this one is similar to Control B. So, Control I, not Control B, Control I. So you can see here, you have the name views here. So let's say I'm going to open the grid 1. Okay, so this grid 1 is a 2D view, or we can say a plane view. But basically, if you click rotate, or if you press control and then middle button of mouse, you can rotate that one as well. And then going back to the plane view, control P, it will be a plane view again. So now, what I'm going to do is I'm going to add the beam. So pick the center of the column and then center of the other column. Then you have now the beam. All I have, and I can change this one to name as beam and then modify. So now I can distinguish which one is beam and which one is the rafter. Okay. So later on I can use that naming convention in our auto connection. Okay. So Control P to make it as a plane, and then close this view, and then go back again to the 3D. All right. Here in this frame, you can add a connection if you like. It depends on the user how you want to continue with the modeling. So create one frame and then copy to the other grid line, or you can just simply finish this connection in this frame. Let's say I want to add a what do you call that? This base plate here. So I'm going to my application and component. All I have to do here is to type base, or you can use the number, the connection number. So let's say base plate, double click on this one. So this is the base plate detail. You can say the part here. I have the 30 millimeter thickness of the base plate, the parameters, the bolt, the positioning of the anchor rod. Let's say this one is 500 here. And then if you like to put the anchor rod, which is D20, all you have to do is to apply and click OK. So in this case, these one are the parameters that you need to fill in able for you to create this component. So apply and then click OK. And then pick the column and then pick the position. And then you have the base plate here. Now, the good thing of using the component here, if I'm going to select these two columns, I can pick one point, and then both columns will have the base plate. And then right-click and then redraw so that I can remove the welding symbol. Now, the good thing of using the component is something like there's an intelligence on it that it will follow according to the size of the column. So this column from HCA 400 to HCA 300, you will notice the changes of the base plate, the changes of the size of the base plate according to the column size. So that one is a good thing using the Tekla structure component. Okay, now I will leave this base plate. All I have to do now is I'm going to select the whole frame and then copy, special, linear. So here from 1 to 2, if I pick 1 and 2, it will show me the direction of the copy. So I'm going to copy that one to the Y direction, positive, and then 1, 2, 3. So number of copies will be 3. So type 3 and then copy. So now it will copy the whole frame with all this base plate detail. So just keep redraw so that you can hide the welding symbol. But if you like to show the welding symbol, all you have to do is to go to this display and then check this weld symbol. Okay. So if I click check and then modify, it will show the welding symbol. But if you don't want to show that welding symbol, all you have to do is to uncheck it and then modify, right? Apply and OK. So now I have this 4 frame. All I have to do is to add another beam. So let's say this beam, I have this HA 300. So I'm going to add again this beam. So from here, 1, 2, 3, 4. I did a double click so that I will start from where it ends. So that's why I use the double click. So now let's see, select this and then copy again this frame, this beam to this grid line C and then to the grid line A. So now I have the supporting beam there. If you can also copy this beam to the Z direction, let's say right click, copy, linear, and then let's say I want to copy this one 1700 going up, copy. So I have now this beam in the at the eaves location. All right. So now let's create now the connection. Okay. So for the connection here, let's start with the connection between the column and the beam. So let's say this one, I'm going to use a hunch connection. So from my component catalog application, then I will just type here hunch. So I'm going to use the hunch number 40. Again, double click the component. So here you can specify the parameters, the one that you want to use. And here, let's say I want to use the beam here. No stiffener. If you want to put a stiffener, just simply put this way. Yeah. If you don't like to put a stiffener, then make it blank. Okay, so you have the choices. Then I have the general, and then hunch. My hunch is a profile hunch. You can use also the plate hunch if you like. Okay, extra plate, chamfer, holes, bolt, position of the bolt. Okay, so there's a lot of parameters that you can choose in, and then all you have to do is apply if you're happy with that settings, and then click OK. So now pick the beam, pick the column, and then pick the secondary part, and then there you go. So again, here, column, and then beam, and then you have now this hunch connection. All right. And then for the eave connection, all you have to do is to use this one, apex hunch. Just double click. Again, use the parameter here. All right. Apply and OK. So pick the first beam or first rafter, second rafter, and then you have this connection. Okay. Now, that one is how you add it manually, one by one. Okay. But if your company have a standard connection, okay, like this one, you know already the connection that you're going to use, whether it is a moment connection or a shear connection. All you have to do is to set up an auto connection. So in auto connection, you need to specify the rules, whether this one is this column is this size and the beam is this size. Then you have to set some rules which connection you are going to use, and also you can use the auto default what kind of attributes you're going to use. So now in this case, what I'm going to do is I'm going to show you how the auto connection works. Okay, but of course I'm not going into the detail of the auto connection. Maybe I'm going to discuss that one in the separate video, how to set up the rules in auto connection. At this point of time, we're just going to show the how the auto connection works. Okay, but first, of course, in Tekla structure, as you know, let's say I'm going to add again this hunch connection here. Yeah. In this case, if I have this bolt near to the near to this corner, okay? So let's say I'm going to change this one to 250, modify. Sorry, not this one, maybe 30 or maybe 70. Still okay. Now, so let us try to check or to do the class check. Okay, so right click and then okay, let me just select objects in component, and then here class check. So for the class checking, okay, you will notice that if I press Control 5, all right, so you can see here the reports. So here, column and beam, it means there's no connection yet, so there will be a clash. So this clash will show you that there is a collision between the elements, and then you need to apply the connection. Okay, now let's say here there is a hunch. So here, if you notice, there is no clash here. But the reason why there is a warning here is because of the erection. What do you call that? Uh, how to bolt or to nut the bolt. Okay, so you don't have much allowance to nut the bolt. So the wrench here cannot be inserted. So this one is also a warning for us. So but basically this one should be okay. All we have to do is to advise the erection people to mirror the bolt. So the head, instead the head is on the left side, the head will be on the right side. So maybe here, if I double click on the bolt, maybe let me check if we can somehow do the changes here. So this bolt, I think you can make this one as a oh, okay, this rotation, instead of front, I'll make it back, something like this. So in this case, this one is okay. You can easily erect this one, or you can easily tighten the bolt here. All right. So the class check is not only for the collision of the member, but also for the erection clearance. All right. All right. So let's go back to the shaded view or render view, and then remove this one. Now I'm going to apply the auto connection. All I have to do is to select everything. So instead of adding the connection one by one to each joint, all I have to do is to select all the members, and then go to this edit, and then you can see here component. Here, select the create auto connection. Okay, so here I have already a predefined setting here. So I have the basic, and then I have the factory default. So it will know which connection are going to, which component we are going to use in every joint or connection. Okay, so all I have to do is to click create connection. Okay, so let's see, create connection. So now, instead of going to each and every joint, all you have to do is to wait for a while, and then let's see how the system works using this auto connection. Okay, so there you go. So it's less than a minute. Redraw, and then let's go through each and every connection now. So here it shows that there is a connection on the hunch, and then this one is a pin plate connection. Pin plate connection, again there's a hunch connection here. This one you can do a little bit of adjustment if you like. So maybe you can change the height of the column. So let's say click this column and then change this one a little bit, let's say another 50 millimeter, enter. Okay, and then let's again redraw, and there you go. Okay, so in this case, this one is a very simple, as I've mentioned to you, this one is a very simple example of a structural steel model. So now what I'm going to do is to create the drawing. Okay, by the way, if you notice, there is a boundary box here. If you don't want to see the boundary box, you can just simply press the Control Shift and then right click and then redraw, and then the boundary box will vanish temporarily. But if you right click redraw, it will go back again. Press Control Shift and then right click redraw, then vanish. But if you like to remove that one permanently, all you have to do is to Control E, and then from the model view you can hide work area, make it false. Okay, now all we have to do next is run the numbering so that we can create now the drawing. So perform numbering, modified objects, as simple as that. Then it means each and every column, if I inquire assembly, so you're going to have a number already, assembly position number. So this numbering will be done by the system automatically. No need for us to assign it to each and every element one by one. Okay, so now that our numbering is completed, so all we have to do is to go to this drawing properties, and then GA drawing. So I have the erection drawing, layout. I can specify the size here, apply. Okay, if I'm okay with that one, the part mark. So my part marking will be assembly position, at the same time the profile. So you can choose any content you like to add in the part marking. Okay. Okay. So now create drawing and then GA drawing. So this time, what I'm going to do is to select the 3D. So this 3D, grid 1, press Control key and then grid 1 and then plan at elevation 3 meters. So what I did is I select 3 views and then I'm going to put that one in one drawing sheet. Okay, so open the drawing after creation. So I'm going to click create. So there you go. So now I have the drawing here. So of course this one is a 3D drawing. I can easily remove the marking on the 3D. I don't need the 3D marking. But if you notice here, all the balls are there, shown there, and then here, this is my elevation. So I can just move this one a little bit, the automatic dimension of the grids, and then you will notice that automatically there is a what do you call that, piece marking with the profile. Okay, this one is the plan. Yeah, so this one again I can move a little bit. This is the plan. And then the good thing for this is let's say we have a modification in our model, let's say revision. So I'm going to change one of this column. So instead of HEA 400, I'll say HEA 500 and then modify. So there you go. So here, if I open again my erection drawing, so as you can see here, there is a question mark because I haven't run the numbering, but you can see that there will be a cloud showing that there is a changes in this particular item. So what is the changes here? Of course, from HCA 400 become HCA 500. This one, the length changed because of the depth of the column changes. That's the reason why this rafter also change, right? So now, let's say I want to have a blow-up detail. I can use now my blow-up detail here in my base plate. So go to the view, select detail view, let's say this, and then put it here. So since this one we're talking about the blow-up detail, so of course we can change the scale. Instead of 1:100, I'm changing this one to 1:10 and then modify. Okay, and okay, now that I have this blow up detail, I can now do the section. So section here. There you go. So this section, actually, if I move the section view here, automatically it will update the section AA, right? So I can also change the view depth. All right. If I don't want to show the other column, so change the view depth. Okay. Again, from this section, you can now add a manual dimension as you like. Of course, you can also add a automatic dimension once you set the rules in the dimensioning tool. There you go. If you like to get the information of this column, just add part mark, and then let's say assembly position, and then the profile, and then modify. There you go. So this one is HEA 400. Okay, so now let's close this, and then this time I'm going to create the assembly drawing. So for the assembly drawing, let's say I'm going to select this column and then this beam. Okay, so I'm going to create the drawing for this at the same time. So let's open the drawing list and then go to this create drawing and then assembly drawing. So this time, whatever the setting in my column drawing is the same in the beam drawing. But later, if you like to differentiate the information in column drawing, you can do it as well. So now, while selecting these two, so I have the beam, yeah, and also the next is the column, yeah. So you can see all the fitting dimensions are there. Now, you may ask, hey, how about the single part? Because this drawing only shows you the fitting dimension. So this assembly drawing will go to the fitter, but as you notice, the single part drawing is not available here. Single part drawing can be in a different sheet, but in case that you want to create a single part here, let's say this, all you have to do is right click, and then you can see here, create single part view. So it means the system will automatically create the single part view. So this is the detail of that single part view. Now, the reason why some of the some of the drawing doesn't have the single part is there are company that they want to separate that one, because the single part will go to the fabrication where they will cut this plate, because here in the fitting, in the assembly drawing, they don't need the details of the plate. All they need to have is the piece marking of the plate, because this detail will go to the production of the plate. That's the reason why they separate it. But in this case, in Tekla structure, it's your choice whether you want to include the single part in the assembly drawing or exclude that one and create a separate drawing for the single part. Okay? So, close this one. Okay, that's it. That's basic modeling and creation of the drawing of the structural steel model in Tekla structure. Thank you.